Okay, so first we're going to do just a quick exercise here. Well, not really an exercise, but presentation about cloud and cloud services. Then we're going to get deeper into some virtualization and some other things in other videos. So let's talk a little bit about cloud technologies and virtualization technologies just a little bit. This is mostly just definitions, the kind of broader information that you might need as we talk about creating our own Linux machines in later chapters. Now, keep in mind for this particular class, you don't have to create your own virtual machines. You don't have to work in the cloud to develop a machine there, other than the cloud environment we've already given you. But it's important that you understand the concepts because they're gonna come up again and again. So just a few slides to kind of make sure that you've got the general stuff on that. So. Cloud computing is the old meme. It's just somebody else's computer, and that's it's accurate, right? So the idea of a cloud computer is that we've built some sort of system or service anywhere, and it's accessible over the internet. And by anywhere, I mean almost anywhere. There are cloud server environments that have been built. Throughout the country, throughout the world, they're experimenting with putting them in the Arctic and Antarctic to lower cooling costs. They're experimenting with putting them out in basically floating environments, again, to use water for cheap cooling. I've no doubt sooner or later somebody's going to figure out how to build these in space. It's not limited by anything except connectivity to the internet. So the cloud is something that you're already using, whether you realize it or not. Email services like Gmail hosted in the cloud. Watching this video, this is technically a cloud service because I'm hosting it through YouTube, which is a cloud provider or a cloud service provider. They use a cloud to hold their services. Netflix, Hulu, Discord, Twitch, all of these things are effectively cloud environments that rely on services. Many of them work through Amazon Web Services, Google Cloud, and Microsoft Azure. Those are our big names in the cloud services market. And the idea here is that you can have a large scale environment. It wouldn't be practical for me to host this video on my own server at home. Even though I don't have a lot of people that watch, the reality is maintaining a consistent connection, keeping a server up to date, making sure that all the security is in place. Those things are impractical. And so small or large cloud services make sense. And typically when we work with cloud providers, they tend to be redundant, meaning they have multiple sites. And they're all over the place, right? So if I have a site in DC and the power goes out in DC, everything switches over to my site in Seattle, right? The users see very little change, but the service continues working. Typically, when we talk about cloud services, we're talking about things that are on demand and elastic, rapidly scalable. What do I mean by that? Well, take the cyber range, for instance. When you all use the cyber range, typically what's happening is a virtual machine is being built for you by a robot, right? It's software, but it's getting built, and then for the 3 or 4 months that we have classes, it's there, it's available for you, and we pay for that time on that server and the time that you use it. And then when you're done, it's torn down, it goes away. It's like it's never there, and we no longer pay for that resource, right? So that's this idea of on-demand and rapidly scalable. It means I can make as many virtual machines as I want. In this case, there are lots of other case studies, but in the case of the cyber range, I can make as many virtual machines as I want. If I'm going to give you 30 different machines with 30 different images, I could do that quite literally with the click of a couple of buttons. I only pay for what I build and what you use, and then when we all go away for Christmas, it goes away, the billing stops, never to restart because it's effectively erased. So scalable. You can see where that'd be very, very powerful, right? So imagine if you're a gamer and is a very popular game stream that you want to watch. As you might imagine, it would be very challenging for a streamer to realize one day, oh, I don't have 100 subscribers, I've got 1 million subscribers, and I need to be able to stream this game to all of them. That ability to be on demand and scale very quickly obviously would be critical. One of the great things about that is it reduces costs up front. So when we build infrastructure, imagine like buying a car. You have to come up with a certain amount of money up front, and then you have to pay every month for the car. If you pay the whole thing up front, then you have to come up with the whole thing up front. And you have to buy the whole car, right? You can't buy like the front tires this week and start using those and then add rear tires later as you need them. That's not really going to work. And IT infrastructure is the same way. We can't buy the routers but not the servers, or the servers and not the routers, or the switches but not the servers, or some servers and not other servers very easily, right? Those things can be challenging depending on what we're building. So being able to say, well, I need this whole car and I need it today, right? And if I need a couple more cars next week, I need to be able to add those cars. And if tomorrow I don't need the car anymore, I want to just give it back and stop paying, right? That's kind of what's going on. We're quite literally leasing an environment. So there are 3 major cloud models. Now the challenge with this is I'm going to say there are 3 cloud models. You need to know the 3. The problem is that there's a lot of crossover between them. So as I describe these, please recognize that if I ask you questions about them, I'll ask questions that are usually pretty straightforward. But in reality, the answer is not always straightforward. There's a lot of crossover. So software as a service, or SaaS. Office 365 is a great example of a software as a service. Canvas is another example. These are things where we don't care about the infrastructure, right? I don't care about the routers, the servers, all that stuff that makes it work. All I care about is this application I want to use. Slack, Discord, Twitch works. And I don't care how it works. That's software as a service. Platform as a service is typically when we have multiple servers built on it. So when we think about the cyber range, it would be easy to think of it as a software as a service, but it's a little bit more than that. It's both an infrastructure and a platform. So specifically, we'll use platform as an example. Platform is Amazon Web Services. So Netflix runs on Amazon Web Services, ironically enough. They also compete with Amazon Prime. But so Netflix says we need a way to deploy our Netflix service, right? And so they go out and they get a platform, Amazon Web Services, and then within that platform they can build their software and infrastructure. And then infrastructure as a service is essentially taking what you might build physically and virtualizing it, or even having it built somewhere else. Some businesses will actually have physical infrastructure, switches, firewalls, routers, security, doors, HVAC, the whole wiring, the whole kit and caboodle, built in somebody else's facility. Why would you do that? Because you don't want to manage it, right? So take example, in a large warehouse facility, and this warehouse has security, perimeter security, armed guards, biometric testing. All the doors are thick steel. It has flood and wind abatement and all of these things to protect what's inside. And inside is a carefully heated and cooled, controlled environment. And in it are essentially big cages, locked cages, and each cage is an infrastructure. Inside that cage are servers, routers, internet comes in and out to them, and it's literally a server room that belongs to somebody else, but you're not hosting that server room on your own property, so you don't have to have your own staff to maintain it and protect it. You don't have to worry about power, you don't have to worry about water, you don't have to worry about heating and cooling. All of that stuff can be handled inside. I use this Virginia Cyber Range as an example. In their case, it's virtualized. They don't necessarily have physical switches and routers dedicated. They may, I'm not sure. But they certainly have virtualized ones. So when you log into an environment, you know that you actually can see multiple machines and that kind of thing. And so they've described an infrastructure that has to exist for them, and they can decide, what technologies, like how can you surf, can you get out of this internet, can you protect other machines, can you attack other machines, and all of that is kind of an infrastructure as a service, sitting on a platform as a service and running a software and a service. So you can see how there's a lot of crossover, but kind of understanding those major bytes is critical. Three typical cloud types: public, private, and hybrid. Hybrid just means a combination of public and private. Public is like website hosting. So for instance, my website is on a server that is hosted by GoDaddy, or you might use Bluehost, or you might use one of the other very popular platforms out there. Maybe you just have a WordPress site. So you don't have a whole server to yourself. You have inside of a server, you have a directory, and that directory is yours. That's considered public, even though it's not, yours is not open to the public. That's not what it means, but meaning even though you're not aware of others, you don't actually know how many other things are running on that site. And there's been some challenges with that over time, because sometimes competitors or vastly different businesses will be running on a similar server, and if they don't do a good job of essentially firewalling between them, that can cause problems. But generally they do a good job of that. Private means I'm buying a whole server. And it may be a big server, small server, whatever. But there's no one else hosted on that device. I am the only one. Typically we do that because we have very specialized needs. We either have a very large website where we need a specific kind of optimization, or very often if we're healthcare, law, any kind of security things that have to be maintained, where we can't risk someone being able to move between directories from a directory they might have access to a directory we have access to. Virtualization. So virtualization is what I recommend you use if you decide to build your own Linux box, at least the first time. Certainly there are benefits and detractors to virtualizing or using dedicated hardware. But the great thing about virtualization is you can spin it up quickly and easily. So let's see if I've got a window I can open here for you. Let's see, VirtualBox. So I use VirtualBox, and we'll talk about this a little bit more as things go. But if I share this window with you, let's see here. Let's add a window, capture, and we'll just drop in VirtualBox Manager. Okay, so now you can see my vManager. So vManager here, this is software that's running inside of other software. So I'm actually on a Mac, and within this Mac I've got this virtualized environment, and you can see in this environment here I actually have a number of different machines running. I've got a Windows 10 vanilla. That simply means that's my root. That's the one I keep updated, but there's nothing else on it. You can see I've got Ubuntu, Kali, and CentOS boxes all available to me. And then I've got a Windows clone, which is just where I actually do work. And then I have my Windows 10 explodable. That's where I do things that I think may break Windows, right? And when they break, it's very easy for me to just reset it and start over. I don't have to do a whole new installation. So a very powerful tool, as you might imagine. So virtualization is this ability to look like hardware to multiple operating systems simultaneously. So in a traditional format, you realize that when you install Windows, Linux, whatever on a machine, that's the only thing. And if you dual boot because you want more than one, whichever one of those is running is still the only one. The other is a file system that isn't running, so it doesn't exist as far as the software is concerned. Virtualization is a little different in that multiple operating systems can exist and run simultaneously, and can be designed to see each other. So as you saw with mine, I've got these multiple Windows machines. I actually can fire all of these machines up at the same time in the same network and work between them. So I can actually try pen testing my Windows 10 explodable from my Kali box, or go from Windows 10 vanilla to CentOS 7 and attempt pen testing and exploits. So they all run simultaneously on the same hardware. This is called a hypervisor. And there are a couple of different kinds of hypervisors out there. So there are type 1 hypervisors, which are bare metal. A bare metal hypervisor simply means it is its own operating system. So in the case of VirtualBox, I install whatever I'm using, Linux, Mac, Windows, and then I install a software called VirtualBox, and VirtualBox then creates these environments for me. Type 1 is a bare metal. It's actually usually a Linux or Linux-based kernel that's very, very small, and it runs right on the metal, meaning it is the primary operating system. And then we build our operating systems on top of that. So they are much closer to hardware, which means they're much faster and they're much more aggressive. So Hyper-V and ESXi are a couple of examples of type 1s, things that are basically designed not to be usable to an end user, but to serve other virtualized environments. Type 2, VMware Workstation, Parallels, VirtualBox are all type 2s, and so they sit on top of another operating system. As such, they provide convenience and access at the cost of some power. And then there's a Linux specific, so things like KVM, Zen, another number of others that are out there that are sort of not quite either type 1 or type 2, depending on which one you run and how you install it. So Linux actually has some that work really specifically for Linux. You also can run things on top of it, for instance, Oracle VirtualBox and I think VMware Player both have Linux variants that allow you to do that as well. And then container images. So I'm not going to talk too much about it, to be honest. I'm still kind of grasping Dockers as a value. But Dockers are essentially containers, and these have been around a while, but they're really starting to grow into their own again, particularly within Linux. So a Docker environment is basically a standalone environment that's totally self-contained. So if you try to run in my SQL class, ITN170, we use PHP MyAdmin. So some of that software actually will come as a Docker image now, or a pseudo Docker image for Mac. But the idea is it has everything you need, all together, packaged with all its dependencies, all kind of completely self-contained, which allows us to insert and remove these images very quickly and easily. We don't have to deal with all the operating system challenges that come with it. Just one last note, when you're working with virtualization, networking is a big piece of the puzzle, and you can absolutely customize your networking within a virtual environment, whether you're using type 1, type 2, KVMs, and whatever. Typically, these are the big ones. You have internal, you have private, and you have public. Internal means it can only see itself, or it can see other virtual machines running in the same hypervisor. Can't see the host, can't see the outside world. Private means kind of a variant of that. Typically, you can set it up to see other VMs. Now, you don't have to, but you can take it up to see other VMs. You can also see its host, the machine it's running on top of, to communicate with that. Some machines I do that with, some I don't. For instance, when I'm running Kali, and I'm doing really aggressive stuff in Kali that I fear might bleed over, I set it up purely as internal, so I can't accidentally do something to my operating system. I can't see my host system and accidentally go after it thinking it's a virtual machine. And then public means it looks just like any machine. It gets an IP address, it can browse the internet, and that's the way I use a lot of my virtual machines. So for instance, when I'm on Linux, I might run a Windows virtual machine because I need to do something Windowsy. I'll run it as a public environment so that I can surf the internet, get updates, that kind of thing. So that's it in a nutshell, and I realize that's kind of a big nutshell of information. There's lots we can do with that. The next few chapters, we're going to talk a little bit about why you might want to build your own machine. We'll talk a little bit about some of the stuff specific to building your own machines, and understanding virtualization comes in handy there, because if you want to virtualize an environment rather than trying to build a bare metal machine, often that's a much more effective way to go. You don't have to blow out your operating system or risk destroying your homework. So be sure to watch the next few videos.